But since we are doing Excel, so we should be slightly exotic, we should use, right? So what we have is, okay, in Excel, the population variance, okay, how do we compute? So please note that the population variance for in Excel, okay, those who are using 2007 or below version, okay, these were the two functions that were there, okay, whereas where P stands for population, okay, and there was nothing for sample. So where was for the sample variance, whereas P was for the population, right? But these greater than 2007 version, these are not being used, okay. So greater than 2007 version to 2010 and above, we have var.p. So explicitly mentioning it is a population variance, and var.s is for the sample variance. So see, var.p is calculate the variance on the entire population, okay? And if I var.s, estimate variance based on a sample. Okay? So if I compute the population variance, I can select this number, okay? I got the population variance. Okay? If I want sample variance, okay, I will do var.s and select the entire thing. So it is var.s. So always remember, sample variance will always be greater than the population variance. Okay. Now, if I ask you, if I want to compute population variance by sample variance, okay, or sample variance by population variance, so it is coming as 1.05. Okay. Actually, this will be nothing but, so you have to count how many numbers are there. So 20 numbers are there. So in population we are using 20, in sample we are using 19. So if I divide 20 by 19, I will get the exact number. See, 1.052. Right? So this is a, statistically you will compute. Okay. How do you compute the mean absolute deviation? Okay. So mean absolute deviation is the formula is, we have computed here mean absolute deviation, or we have computed using absolute value like this, but Excel has a very short and sweet. Okay, it is your AVE-DEV. So AVE-DEV, you see, returns the average of absolute deviation of data points from their mean. So AVE-DEV, I can compute for this data set. I got 39.15. If I apply AVE-DEV here, AVE-DEV on this data set, just want to concur whether the values are coming same or not. See, 36.75, this was 36.75. So we don't have to do these calculations. This was for all our understanding purpose only. So mean absolute deviation is coming from AVE-DEV. Right? And range, how do you get the range? Simple, you compute the maximum, subtract from it the minimum. So subtract from it the minimum. So you will get a range. So in this case, the range is 231. Right? But a range is the worst kind of dispersion calculation. Okay. The best kind of dispersion calculation is your sample variance. Okay. But again, the variance is a squared unit, so we don't want to take. So we'll compute the population standard deviation and we'll compute the sample standard deviation. So how do you get the population standard deviation? So this is a formula, STDEV, and as you know, dot P means population, dot S means sample. Okay. Before 2007 or 2007, STDEV was population and STDEV was the sample. Right? So this, if you see, you have STDEV A. Okay. So see this, whenever you get A, count A, etc. So you can see that estimate the standard deviation based on sample, including logical values in the text. Okay. So if there are some logical values in the text, then you should use STDEV-A. Okay. I'll show you that one. Okay. So as of now, STDEV.P will use. Okay. This is our number. Let's say we have some 3 more data set will come. As of now, I have computed. Okay. So population is standard deviation. Okay. I have selected, guys, you see B3 to B25. Okay. Now again I will do the same calculation, but this time I will select B3 to B22, only 20 items. Okay. You see that the numbers is same. Okay, even though I have selected these numbers, okay, it is this, since these are blank, they are ignored. Okay, so here and here it was up to 22, here up to 25, it is ignored. But the moment I put 0, okay, you can see that there is a difference between the two. So this is 25 is counting that 0 as a number. This does not have that value. So please note that a number is not there, it doesn't mean 0. Nothing is there, it's blank. It is not taken into consideration. If I write A here, okay, again it is not taken into consideration. If I write AA, it is not taken into consideration, right? Now let's see, we write another formula, STDV A, okay, and we give the values, okay, up till the end. Okay, see this value is 58.2235. Okay, this also was selected till here, this also is selected till here. Okay, so it means that it has considered these numbers, okay, as some value, okay, and doing the computation. So until unless you are very sure, don't use this STDV. Now we are not sure that what this A stands for, right? So if I remove this A, okay, what will happen? And if I remove this double A, okay, what happens? Okay, so we are not sure what exactly is this all computation about. Okay, so we don't select this. Okay, this is, as of now, this is not in our scope, so we are not covering. Just was illustrating. Okay, and sample standard deviation STDV.S, and you have, so select only the numbers that you can see. Don't select any other thing. Okay, so this is your sample standard deviation. Okay, right? So we have these functions using which you can, these are statistical functions, we are able to compute this. So sum of square dispersion also. So sum of square dispersion, so sum of square dispersion, how you will calculate? This is STAVE, dev square. So dev square, okay, is your the sum of square dispersion. And if you take the total numbers that we have, total numbers can be computed using count. We already have seen this. So 20. If I want to compute the variance population, I can also compute like this. Sum of square dispersion divided by the total number. So this is coming same as the population variance. Even though this is a descriptive statistics, I want to cover something called a standard error. Okay, standard error is mostly used in the inferential statistics. Okay. But what is the standard error? Okay, standard error, if you see the formula, okay, standard error, okay, it is some kind of error. Okay, error is like when you are estimating something, some error will come. As of now, standard error is just given as sigma by root n, where sigma is the standard deviation. So sigma by root n is the standard error. Okay, so since we have standard deviation, we have population standard deviation, we have. So standard error can be for both population standard error, okay, and it can be sample standard error. Most of the time it is the sample standard error rather than the population. But population standard error will be population standard deviation divided by root of 20. So another way to compute the root is SQRT, SQRT 20. That is the population standard error. This is your calculation. Okay. So these are some of the dispersion measure, okay, that you have seen. Okay.